1A is talking about exponential functions. We are going to start to analyze the graphs, find the characters of equations and graphs, and also be able to do regressions to find the actual regression equation for an exponential function. If we take a look, exponential functions are written in this form. They are always y equals a times b exponent x. A is always your y-intercept or starting point. B is known as your rate of change, which is always called your multiplication factor. So the B number is the one that tells you it's exponential. It tells you how much it's going up by. Is it doubling? Is it tripling? Is it going by 1/3? Is it 5/2? How big is it? What is it actually doing? Now, we have two situations where B can be larger than 1, or B can be, greater than 1, or it can be a decimal between 0 and 1. We also start with b to the x. If we have b to the x and we don't have an a there, there is an a. It's a hiding 1. So there is a hiding 1 right there. So a equals 1. So our y-intercept in this case would be a 1 when we only see b to the x. So whenever you see one digit with a variable as an exponent, the 1 in front of it is always a positive 1. So this guy is going to touch the x-axis or the y-axis at positive 1 for a y-intercept. All right, here's our first one. We're going to talk about this guy. So we know our y-intercept has a hidden 1 in front. We're going to analyze this graph. So what we're going to do is we're going to stick 3 as our base of our exponent. We're going to use all of these x values in our list or table of values as the exponent number. So if I go 3 to the exponent -3, I'm going to get 1 over 27. If I go 3 to the exponent -2, I'm going to get 1 over 9. If I go 3 to the exponent -1, I get 1 over 3. We know that anything exponent 0 is going to give me a 1. 3 exponent 1 is going to give me 3. And 3 squared is going to give me 9. So you're going to see the numbers, basically, these ones are reversed, right? Negative exponents, they're going to be the flip value, correct? So that's what's going on there. So what is going on with this guy? Well, he's starting way down here. So at -3, we're starting with dots way down here. -2, I'm getting a little higher. -3, I'm getting a little higher. But when I get to 0, I actually touch positive 1. So all of these numbers here are below positive 1. My y-intercept is positive 1. Your y-intercept is always when x is 0. So if you have a table of values and you don't know which one it is, look for where x is 0. The number on the right for y is always the y-intercept. Now we graph the next point, 1 and 3. I go to 1 and up to 3. And then I go to 2 and 9, which is going to be way up here. We can see that this does graph an exponential equation. An exponential equation, if we continue and graph our line, our dots, it's going to look something like that with a curve. Okay, I've got a curve coming through here. Okay, we call this kind of a function an increasing function. So he's an increase, he's going up. The x-intercepts, did he touch the x line here? No. So we're going to say none. There are no x-intercepts. And that's one of the features of an exponential graph. There will never be any x-intercepts. It will come very close to touching x, but x-axis is considered its horizontal asymptote, which is a line it approaches but never touches, if you remember from 20-1. Over here, the y-intercept we found when x is 0 is positive 1. We write it as a coordinate point. So it's going to be written as 0, 1. The domain for any exponential, domain and range refer to the boundaries on x and y. If I take a look at my x boundaries, am I in the left-hand side, the negative on the x's? Yes, I am. Am I on the right-hand side of the positive x's? Yes, I am. So are there any boundaries on x? Can I go left or right here anywhere? Yes, I can. Since I can go on either side of this graph, left and right for x, there are no boundaries on x. So how do we write no boundaries on x? We say x can be any real number, or xer. So we write it as xer. Now domain and range can be written as a very specific set theory notation. we would actually write domain, we would write it like this with set theory notation. We would say domain with curly brackets. The curly brackets are called braces, something like that. And we would have X and then a straight line down. The straight line down means such that. So I have X such that X, and then I have a funky letter E, capital E, that looks like a curve sort of. And that means can be a part of or can be a member of. So that means that X such that X can be R meaning a real number. And that's how I would write that down. We've always shortened it just to say XER, but this is how we would actually write it. And that's what you need to be able to write down. So X such that it's any real number. Our range, if you take a look at the graph again, the range is a little bit different. Do I have boundaries on my Y numbers? Well, if we take a look at Y, it's the vertical axis. I'm above on the vertical axis, but do I go below the 0? No, I don't. So that means on this part here, I never use it for an exponential graph. So that means there's a Y value, a Y boundary. That means that Y has to be above this 0. I cannot touch the 0, it's got to be above the 0. So now my range is going to have a boundary. I would write it like this. Range, oh, not a very good bracket. Let me try again. Yeah, there we go. Okay, so we have Y such that Y must be greater than 0, comma, Y-E-R. Why is it Y-E-R at the end? Because as long as we are above 0 on our graph, it can be any number. It can be decimals, fractions, radicals. It can be any number in here as long as it's above 0. Okay, the XER and YER part means that it can be any type of number. It could be a negative, a positive, a fraction, a decimal, a radical. We've dealt with those in the past lesson. So that means any of these numbers. I could have 5 root 3 on here. Is that a possible number? Yes, it is. Okay, so it's a possible Y value. I would come up here, 5 root 3, come down, there's my X number. So it would intersect my graph. So this part here is saying, as long as I stay above 0, then Y can be any number above 0. That's what it's telling me. End behavior. End behavior for any graph refers to the ends of your graph, meaning the graph line itself is supposed to have arrows on either end of the graph. Your graphing calculator doesn't put arrows on them. It'll just take up the full screen. So there should be an arrow on the end of this and an arrow on the end of that. That just means they continue in both directions continuously. And what it also means is it's the end behaviors. These are called the tails. Okay, that's one tail and this is the other tail. So it wants to know which quadrants of your graph is the tail in. So if I take a look, I have to remember which quadrants of my graph are. We always start with quadrant 1, quadrant 2, we have quadrant 3 on the bottom left, and quadrant 4. So the quadrants that we always use for our end behavior of an exponential, we're always in quadrant 2 and going to quadrant 1. So we would say quadrant 2 to quadrant 1. Okay, quadrant 2 to quadrant 1. Now, if you're using the Roman numerals, you don't need to put the letter Q for quadrant. If you use digits, you must put the letter Q. I could also write it like this, Q2 to Q1. If it doesn't want to be written that way, it could just be 2 to 1. Roman numerals alone mean quadrants. Okay? You can mix them as well, it doesn't matter. All 3 ways are correct. Now it says the horizontal asymptote. It wants the equation of that. The equation of our horizontal asymptote, well, we need to remember what that horizontal asymptote, those are big words. What do they mean? Well, this means it's a horizontal line that it will never touch. So it's a line, the graph never touches. It will approach it. It can come very, very close to it, but it will never touch that line. That's what a horizontal asymptote is. And for exponential graphs, our horizontal asymptote is always the x-axis. So here we would say always the x-axis. Well, along this x-axis, what do we know? Y is always a 0 on that axis because it doesn't go up or down on the x. So we call that our y equals 0 equation for that line. So the equation of our asymptote is y equals 0. Whenever we see y equals 0, that's saying that's your x-axis. Okay, so y equals 0 means x-axis. Okay, if I had a vertical asymptote, that would be the y-axis. And the y-axis, you switch the letters, it would be x equals 0. Because all along this line, the vertical is x equals 0. That's how we get our y-intercepts. Along this line, remember, our x-intercepts, we always get an x number, but y number is always 0. Those are x-intercepts. Okay, that's why it's called the y equals 0 line. Okay, let's move on to the next one. Now we've got a different b number. Before we had a b who is a 3, and we noticed it went up. Now we've got a b who is a 1/3. So what we've got to do is we're going to go 1/3 exponent 3. We're going to go 1/3 exponent, negative 3, then negative 2, then negative 1, then 0, 1, and 2. We're going to find the exact opposite. It's going to go 27, 9, 3, 1, 1/3, 1/9. So if I find negative 3, it's way the heck up here at 27. It's way off my grid. I can't even find it on my grid. But I can find negative 2, 9. Negative 2, 9 is about there. Negative 1 and 3 is about here. Then I've got 0 and 1, my y-intercept. Then my next 3 numbers are down here. Okay? So I'm going to notice this graph now is starting up here and coming this way. So I would say this is a decreasing graph. It's going down. When you read graphs, you always read left to right like you do a book. So if I was reading left to right, I would look at my left tail here. My left tail starts above, and then it starts to decrease and go down. That's why it's a decreasing graph. We never read them from right to left. It's always left to right, just like you read a book. My x-intercepts, again, there'll be none. It'll never touch this x line. So there's going to be none. Our y-intercept is where x equals 0. So find x equals 0 either on the graph or on the table of values. We know it's 1. So 0, 1. Our domain, again, we're going to write domain as x such that x can be any real number. And that's what it means when I write it that way. Our range will be the same as before. It doesn't go below 0. So I have to write my range as it will be greater than 0. So range is going to be y such that y is greater than 0. And then I have y-er on the end. End behavior, talking about the tails. Where'd my tails go? Well, I'm starting in quadrant 2, and again, I'm ending in quadrant 1. So I'm going Q2 to Q1. Quadrant 2 to quadrant 1. And my horizontal asymptote, the x-axis, the line that we never touch, that's our y equals 0 line. So you could say y equals 0 because it wants the equation. So you have to say something equals. And we always know that that's our x-axis, a line that never touches. There's 2 more on the next page we are going to talk about together. This time we get an a value and a b value. So 2 different graphs. We're going to graph them on the same one here. And we get an a value and a b value. So it is written this way. So I would label this a, there's b. Here's my A, there's my B. So if I graph the first one I know is going to touch positive 5, because that's my y-intercept. A is equal to the y-intercept. Y with a little baby I like this, a superscript, or subscript, that's called y-intercept. So my first one, and it's doubling. So my first graph's going to come up and go up. My last graph starts at +4, and 1/3, it's getting smaller every time. It's dividing by 3 every time, which means he's going to go down. So if we throw those equations into your y equals, put one into y1 and one into y2, you will see exactly this on your calculators. So please enter your calculators, go y1 and y2 in the y equals, and put each of those. This guy is into y1, he is into y2. Use brackets with a fraction always. And yes, the 2 has to be in brackets as well because it's sitting beside the 5. So if you put those into your y equals and graph it, you'll have a graph that looks very similar to this. And we will see that A is increasing, B is decreasing. X-intercept, none. It'll never touch X-intercept. Yes?
How do you get
The X, the variable X, it's right beside, it says X theta Tn, it's right beside your alpha button. That's your X. Remember, your X is your exponent, so you need to use your TP button for the exponent. Okay, our y-intercepts, that's our A value. We're looking for the A numbers. Well, our y-intercept here is going to be 0, 5. The y-intercept over here is going to be 0 and 4. Is everybody able to see their graphs?
No.
No?
No.
Okay. So if we take a look in your calculator, you hit the y equals button and you put these in, you'd have 5 bracket to bracket. Exponent is above the divide sign. It looks like a little teepee. You go exponent, and then your X button's beside the alpha button, and you hit X. Then you hit your down arrow, going to Y2, and you type in the second equation, 4 bracket 1 divide by 3. That's how you type in a fraction. Close your bracket, exponent X. And then you hit the graph button, and you'll see your graphs. You just didn't go that fast? Okay. So does everybody have that looking for them? Okay. Excellent. Okay. Domain and range. Let's take a look at domain and range. What would our domain and range be for these? Is it going to be identical? Yes, they'll be identical. How come? Because they're exponential graphs. Do our graphs go below 0? No. So the range has a boundary. Does it go on the left and right? Yes. So X doesn't have a boundary. So we need to tell us that. So domain is going to be X such that XER. And then put your funky brackets, the braces. The range, I'll just write it, and it'll be the same over here. Okay, it's the same over here. They both have the same domain and range. Your range is going to look like Y such that Y has to be greater than 0, YER. As long as it's above 0, it can be any number. In the end behavior, what did our tails do? 2 to 1, still, always. Q2 to Q1, Q2 to Q1. Horizontal asymptote, the line it never touches, is our x-axis, which is y equals 0. And that is standard. You're going to notice that this stuff right here is the same always, and so is the x-intercept part. That is always the same for any exponential graph. Those are considered standard characteristics that'll never change for any exponential graph. Now your x or your y-intercepts will change depending on where they touch on your y line. Whether it goes up or down will change. but it's not going to change your X and Y domain and range, and it won't change your end behaviors or your asymptote. Well, how are we going to create a graph or a table of values or an equation if we're only given a graph? There are strategies, and here are the steps to do it. So it says if you've got a graph, you need to create a table of values using -1, 0, 1, and 2 for the X values. So I'm going to go to my table and put in -1, 0, 1, and 2. Then it says find these points or the other points on the graph and match them up and find the Y numbers. So if I go to my graph and I find -1, I'll go to -1 and go all the way up. -1 becomes 8. And if I find 0, I'll find 0, and it comes up here. 0 is at 4. If I find +1 and go up, +1 is at 2. Then I go to +2, and is it +1. Then it says step 2. We can enter this into our data, into our lists, and do an exponential regression. We're going to do that. That's our next step. But before that, we can create one just by looking at the table of values. We look at our Y list. It says find a pattern in the Y list and see what's happened to the Y number. If we see what's happened to the Y number, Austin, what do you think's going on with this Y number over here? By how much? Yeah, it's dividing by 2 every time. Well, if we divide by 2, that's the same as timesing by 1/2. Timesing by 1/2 is the same as divide by 2. Because when we want to divide by any number, we'd always flip it in times. That's how you do fraction rules. You flip in times. So we know that our B number is 1/2. We also know that our B number has to be between 0 and 1. It's got to be a fraction with a small number on top because it's going down. It's going down. Does everybody see it's going down? Good. Because it's going down, our B number has to be a fraction. So we know B is a fraction. Well, we know it's dividing by 2, so our B number is 1/2. Now, our A number is always the Y-intercept. So what's our A number here? If we look at our Y-intercept, it's when X is 0. What's our Y-intercept? 4. You can find it in the table of values, or you can find it on the graph, your Y-intercept. So my A is 4. So this equation that we would write would be this. Y equals A times B exponent X. There's our equation. And now we're going to do the regression steps to find that in the calculator. The regression steps are going to be coming up in a few moments in our notes. We're going to do this question then. So if you look at page 5, the top of page 5, it's got your regression steps. So our regression steps start right here. So you hit the stat button and the enter button. So if I want to do a regression, I'm going to follow exactly every single one of these steps. So I'm going to hit my stat button, which is right beside, I'm going to debug them, hang on. Close. Debug. Okay. So if I go now to my stat button, I hit stat button, which is right beside under my delete, beside my left arrow. In stat, you're going to see edit, number 1. Hit enter. That's where our lists are. You always have list 1 and 2. Sometimes you need to have 0, 0 in there so that your calculator can see the graph. Sometimes it won't graph without numbers in your lists. This one's got nothing in there, so I need to put the numbers in there. If I look at my numbers, the question that I'm going to be graphing is the question we had on the bottom of page 3, which my X numbers are -1. After you put a number in, you hit enter. So -1, enter. 0, enter. 1, enter. 2, enter. I'm done with my first list. Now I hit my right arrow, the large arrow on the right, and it switches to list 2. Now I'm going to put my list 2 numbers. I have 8, enter, 4, enter, 2, enter, and 1, enter. Now, oops, to the 4, into a 1, enter. Okay, now I'm at the next step. I can go to the step where it tells me, I hit my stats button again. I'm at step 3, so I hit my stat button. Now I go over to the right arrow, and it highlights calculate. So I'm going to calculate. This is where I have my list of regressions. I know this is exponential, so if I scroll down my list, I'm going to see 0 is exponential. So I'm going to hit 0, enter. Now don't hit enter again. You're going to hit what's called the vars button. So your vars button is right beside the clear button. You hit vars, the right arrow across the top to Y bars. Why is this step important? It's telling the calculator to put the equation in the Y equals button so that you can actually graph it. If it doesn't go to your Y equals button and it just puts it on your main screen, you won't be able to see the graph. So now we tell it, go to the Y equals. So now this is saying enter, and you enter 3 times. We want it in Y1? Yes, we do. Enter 3 times. There's my equation. Yes, it's on my main screen, but because I put the Y equals, the Y bars part, I can hit my Y equals, and it's still there. It's now there. Since it's in your Y equals, now you can hit your graph button, and it can show you the graph. Okay?
Can you do that all over again?
Yes, we can. Yeah, absolutely. Let's try this again. Okay, so now from regressions, we're going to go back to matching graphs. Okay, matching graphs. We all read through this. We have start with the Y-intercept. We see what the A value is. We match it according to the Y-intercept. So if we go to the graphs on the next page, we can see our Y-intercepts. My Y-intercept on this graph is a 3, so I'm going to find the Y-intercepts with 3. This guy has a Y-intercept of a 2, this one has a 3, this one has a 4, and this one has a 4. So this one, with the only Y-intercept of 3, I have only one choice, 53.
One more important announcement.
Okay, the next one I can do that's very easy is a 2, a Y-intercept of 2. I can match it up very quickly. There's only one Y-intercept of 2, so that's graph 4. So graph 4 over here is A. The only tricky part is I have 2 that have a Y-intercept of 4. So that means I have to look at the B letter. If you look at the B letter, this guy is a 3, this guy is a 0.5. If he's a 3, it means he's going up. This guy with a 0.5 means he's going down. So that means that this number 2 has to match this graph because he's going up. So number 2 is going to match B, and this guy here is going down. So he is going to match graph 3, and that's how we match those. We are going to enter the example 1 into our list. It's a horizontal table value, so list 1 is always the top value, list 2 is always the bottom. So now I'm going to go list 1, list 2. I'll give you a couple minutes to put equation 1 or example 1 into your lists. Once now that we've got list 1 and 2 into our lists, I do a regression for my exponential, and I'm going to notice it comes up like this. It's going to say A equals 6, B equals 2. I'm going to write my equation like this for example 1. I'm going to write Y equals 6 times 2 exponent x. There's my A value and my B value. I just rewrite them now as an equation. I will give you a couple moments to put example 2 into your lists and do the exact same thing. You did notice this example was an increasing example. It was an example that went up. How come? Because our B value is greater than 0. It is greater than 1 actually. Now that you've got example 2 in your lists, again, it was list 1 and list 2. We do a regression. We're going to get A is equal to 4096. And we're going to get B is equal to 1/4 or 0.25. We math frac that. That gives us 1/4. So when we write our equation, for example 2, our example equation is going to look like this. 4096 is our A value. Our B value is 1/4 exponent x. Now we also know this is a decreasing function. That's what our graph shows us it is going down. And why is it going down? Because we look at our b value. Our b value is a fraction between 0 and 1. Between 0 and 1 means it's going to go down. Now we have a couple diploma questions we're going to look at. This one here says what the situation is being modeled by the graph. Here it tells us if A is greater than 0, so our y-intercept is larger than 0 in graph 1, and the value of B. So I have a y-intercept in graph 1. It's talking about graph 1. They gave us graph 2 just to confuse us as too much information. If we read the question, it's actually talking about graph 1 only. So graph 1, I look here, and it's going up. So since it's going up, the B has to be larger than 1. So B has to be larger than 1. If we take graph 2, another question for numeric response could be, okay, well, graph 2, what is a possible y-intercept? A possible y-intercept could be a positive value. What is your A value? Well, A value is your y-intercept, and your B value in graph 2, your B value has to be a fraction between 0 and 1 because it's going down. So if we were answering this question as a numerical response, saying which one of these, A, B, C, D, they could have been labeled as 1, 2, 3, and 4 for numerical response. Which one describes what the B value in graph 2 is doing? The B value is going down, so that means the B value has to be between 0 and 1. So that's what's going on with graph 2. Now our next question is a diploma question again, and it's matching equations to their graphs. Again, we can match them according to the y-intercepts. So we look at our y-intercepts. First, this guy has a 0.5 y-intercept. So 0.5, this one has a 3, this one has a 3, and this guy has a 2. So the highest y-intercepts are 3s. So the highest y-intercepts are the diagram 1 and 2. So I know diagram 1 and 2 have to be a GX or an HX. But how do I decide who is who between diagram 1 and 2? I decide by looking at the B value. I need a B value here. This one's going down. So B has to be between 0 and 1. Here the B has to be greater than 1 because it's going up. So by knowing that information, I know that this guy has to be GX because he's going down with this B as a fraction, and this guy has to be my HX graph equation because my B value is a 2 and it's greater than 1. Looking at diagrams 3 and 4, their y-intercepts are very different. I have a small y-intercept here, so this could be my y-intercept of 1/2. So my A value is 1/2 here, so this could be graph of fx, it would match. And this one here, diagram 3, our only one left is going to be kx. So if we were writing this down as a numerical response, who would be matched if we wanted in the order of F, G, H, then K? I would have my answer as graph 4, graph 2, graph 1, graph 3. That is what we would write in our numerical response box if they were written in this order of our equations of fx first, then we put gx, then we put hx, then we put kx. That is the order they would be in. The rest of the questions are for you to practice. This concludes lesson 1.1a.